Hello everyone, this is our finfish monitoring project for Upper Buzzards Bay and the greater northeastern coastline that was conducted at Massachusetts Maritime Academy. My name is Jack Guerrier.
My name is Michael.
My name is John.
My name is Nathan.
My name is Matt.
Our research objectives fall under a single goal, which was to conduct an intensive finfish and American lobster sampling effort using diverse capture methods and to deploy onset hobo data loggers in the Upper Buzzards Bay region at Massachusetts Maritime Academy to obtain specimen data, monitor changes in coastal conditions, conduct data synthesis, and to inform future management efforts. We had a series of objectives. First was to deploy standard lobster traps, standard fish traps, and onset hobo temperature and conductivity loggers, as well as onset hobo pH and temperature loggers. Our second objective was to capture, tag, and recapture as many juvenile and mature finfish and American lobsters as possible. Our third objective was to record probe data, specimen data, and trap data into an online shared drive. And finally, our fourth objective was to summarize and compare findings with historical data and to reflect on current methodologies used. At the start of the experiment, we proposed a number of research questions to go along with our project. First was to determine if there is a discernible correlation between the frequency of finfish capture and seasonal change in the marine environmental conditions. The second was to determine if the temperature dictates the time of migration for all finfish species caught. And the third was to ask whether or not the species that were successfully captured would have a high incidence of recapture. So this would be indicative of site fidelity. So this is an opportunity for recreational and commercial fishermen to contribute to a local finfish monitoring effort, and also an opportunity to assess site diversity and form an index based on the captures to determine ecosystem health.
So throughout this project, we also obtained and assessed various coastal species of saltwater fish. So we looked at black sea bass, we looked at tautog, striped bass, scup, cunner, and summer flounder. We also cataloged winter flounder, butterfish, northern pipefish, and shorthorn sculpin.
Alright, so this is our slide on black sea bass, code BSB. We caught a total of 217 sea bass with a mean total length of 15.7 centimeters with a max length of 66 centimeters and a min length of 5.1 centimeters, leaving us with a range of 60.9 centimeters. In total, we tagged 46 black sea bass and we had 2 recaptures, giving us a recapture rate of 4.35%. And of those 217 black sea bass that we caught, 215 of them were females and 2 of them were males. And then if you look at the bottom right at our graph for total captures by month, you'll notice that in October we actually caught our most sea bass with a total of 120. So this is our graph representing the relationship between total black sea bass caught and temperature. And you'll notice that as the temperature drops from 21 degrees Celsius in September to as low as 7.9 degrees Celsius in November, that there is a general decrease in the amount of black sea bass caught.
So these are our stats for tautog, code TT. So total captures was 225 fish. Mean total length was 31.6 centimeters, with a maximum of 53.4 centimeters and a minimum of 6.4 centimeters, giving us a range of 47 centimeters. The total tagged fish was 174. Total recaptures was 8 fish, giving us a recapture rate of 4.6. Total females caught was 79, total males 55, and the total unidentifiable was 88. This graph shows our tautog captured and water temperature. As you can see, as the temperature went down, the capture rate of tautog went up.
So for striped bass, code number SB, we had a total capture of 62 fish. And from the graph on the right, you can clearly see that we captured most of these fish in October, mainly because we hypothesized that would mostly be because it's not too cold. The water's not too cold yet, but it's not too warm, so it's kind of like the perfect temperature for them. And we have a mean total length of 62 centimeters, with a max total length of 72 centimeters and a minimum total length of 45 centimeters and a total range of 37 centimeters. So the total amount tagged were 62, total recaptures were none, and recapture rate was 0%. And for most of the striped bass, we caught them with hook and line, and we did not catch them in the fish traps because, of course, they were too big. We didn't even catch juveniles in the fish traps. We mostly caught the tog and black sea bass. So this graph shows the striped bass and temperature, and basically it shows the temperature correlation on the y-axis and the dates we caught the striped bass on the x-axis, and you can clearly see that there are more fish caught during the warmer climates, around 25 degrees Celsius, a little lower, and towards the colder months we caught absolutely no striped bass. Particularly we stopped catching in November 12th. We suspect that the striped bass started moving into warmer and more temperate climates.
The next species that was included in our study was scup, code SP number 4. We caught a total of 24 individual fish. We obtained a mean total length of 24.9 centimeters with a standard deviation of 8.1 centimeters. So our maximum total length for scup was 32, our minimum was 8.6, and it ranged by 23.4. And none of these fish, unfortunately, were able to be tagged. And all of the scup were captured in the month of October. Here we have a graph depicting the relationship between sea surface temperature and the frequency of scup captures over time. All of the scup captures were obtained in the month of October, when water temperatures were marginally warmer than in the month of November. And after this month, no captures were obtained.
So for Cunner, in total we captured 415 fish. Our mean total length was 10.9 centimeters. In total we tagged 15 fish, with 4 fish recaptured for a recapture rate of 26.7%. And as evidenced by the graph, we captured the most Cunner during the month of November and the least amount during the month of September. So as evidenced by this Cunner temperature graph, you can see that Cunner prevalence within our traps and also captures via hook and line were minimal in those warmer periods, but as the temperatures sort of steadily diminished, Cunner levels increased exponentially.
Alright, this is our slide pertaining to northern pipefish, code PF. And in total we caught 3 northern pipefish with a mean total length of 15 centimeters, a max total length of 16.9 centimeters, and a min total length of 14 centimeters with a total range of 2.9 centimeters. Due to their size and our lack of equipment, we did not tag any of the northern pipefish. And if you look at the right, you can see our graph correlating the temperature and the amount of northern pipefish that we caught. But due to a small sample size, can't really say that there is much of a relationship between the temperature, the drop in temperature, and the presence of northern pipefish. In conclusion, black sea bass and striped bass populations became scarce as water temperatures decreased from September to November, per graphical analysis. Among the fish that are cataloged within our study, tautog and cunner remained within upper Buzzards Bay for the greatest length of time, far into late November. However, we weren't able to capture any American lobsters in any of our lobster traps throughout the study period, and initially we wanted to incorporate their population dynamics and how shell disease affects the given populations in Buzzards Bay. And it also can be noted that all of the fish that we captured appeared in very fair health and none appeared to have any type of disease.